Okay, good afternoon. Can you hear me?
Good afternoon. Good afternoon. Yes.
Okay. Today we are going to continue on perforation chapter. Before starting with the lecture, I would like to mention some points that are very important for this semester and next semester, both on assessment and marking and grading, etc. First of all, tutorials. As you must know, because in entrance lecture, I mentioned some points from the syllabus, and you probably have seen in the syllabus that 15% of your marks will come from the your activity, your homeworks or tutorial performance during the tutorials. And this will come from the tutors that are providing the tutorials, Mehmet Malim and Elnare Mehmet. There will be a couple of quizzes that I will place on the LMS platform, which you will have to complete before the exam, which also will be counted into this 15% as a 5%, as a 1/3 part of this total 15%. So 5% will come from the quizzes from the LMS, and the rest 10% will come from your performance on tutorials. So please be active, proactive in the tutorials, and the feedbacks from the tutors will be basis for your marking as a before exam marks. Secondly, attendance. I'm receiving some emails about or messages about somebody is not reaching internet or whatever. Again, as I said, from the day first, I'm not controlling any attendance. I am just a registering attendance. Whatever questions about the attendance, you have to talk to administration, like Rima Hanım, Zafer Meryem, or Samira Hanım, because my job is just register who is in, who is not in. I cannot register the people who is not in. So whatever excuse you have for that, and I'm sure it is a respectable excuse or real excuse, please refer to, again, Zafer Meryem or Rima Hanım or Samira, to the administration. I can understand your problems, but this is not my duty to make registration for those who is not in the class. Okay. The last thing I would like to mention is scientific conference, if I'm not wrong, in April. And I would encourage every one of you to start working on some research paper or presentation. I would suggest to, as long as you are doing the research for your first semester program, you can make a thesis for this research and make a presentation for this research for this conference with a little bit more elaborating around this subject. Okay, so please make sure that you think about that and prepare, work on this research subject to present on this conference. Think about that and talk to your supervisors. I will talk to my students in private conversation when we meet online to discuss the research project's progress. Okay, can you see this slide?
Yes.
Okay. Any questions about the topics I covered before we start? Is everything clear with the marking scheme, with the tutorials importance? I hope silence means agreement. And
can you hear
attendance,
me? Hello?
Yes.
Ah, great. Thank you. Yeah.
Okay. Now, let's sorry. Let's continue on the lecture. Last time we stopped on the assessment of perforating charge performance. How it's done, we mentioned that there are some test methods or the API recommended practice, which is called 19B edition. And the purpose of this document is to specify the materials and methods to evaluate objectively the performance of perforating systems or perforators. Okay. The section 1 is, as we mentioned before, section 1 is assessing the performance under ambient temperature and atmospheric pressure conditions. And what is done, there is a test briquette or cement casing and cement with concrete, which let dry for 20 days and compressive strength of which at least 4,000 psi. And then they fire the guns at certain spacing and shot density. And then they measure the bore height on the casing. The bores are these deformation on the casing when you shot the well with the perforators. So these are very important to understand how they are formed, what are their heights, etc., etc. And then they measure the average diameter of perforations and the length of perforation. So this is to understand what dimensions we achieve by doing by perforating at this shot density at certain explosives and charge weight what will be the perforation length, the average diameter of perforations, and the bore height on the casing. And as I said, the gun position and clearance for all shots are also recorded to understand how these guns or charges are performing. Section 2 simulates the downhole conditions in laboratory to understand the effect of charge size on soft or hard formations. Here we have a charge and we have a core core samples, and the converting perforation length measured in the standard target to downhole penetration length by correcting for casing, cement, in-situ rock stresses, rock strength, wellbore pressure, gun clearance, etc. etc. But here we test on core sample and with different charts how long the typical perforation length will be in this type of core sample. And these core samples may be different from different rocks, from different formations, and testing how it will affect the soft formations or hard formations, and then it is converted. These numbers are converted into the perforation length, taking into account the effect of casing, effect of cement, in-situ rock stresses and rock strength, etc., etc. Sorry for this slide, something wrong with this slide, but the section 3 usually tests the performance of the charge of the guns after the exposure to elevated temperature conditions. So here we have a charge and thermal bands, and this is how we tested what the effect these elevated temperature will have on this charge on the performance itself. Sorry, this slide is wrong. I will correct it and will present separately. So, finally, section 4 is heat test on performance degradation of gun systems resulting from thermal effects, and API recommended practice number 19B. Section 5 is quantifying amount of debris that exits a perforating gun following detonation at retrieval. Okay, so in this section 4, we test how the performance of gun system degrades due to the thermal effects. Okay, so minimum of 6 charges are fired from heated gun system into steel plates, and then penetration and entrance hole diameters are at elevated temperatures are compared with those from guns fired at ambient conditions. Okay, perforating company or company that provides perforation systems have in their books this type of tables. This is from Schlumberger. There are other manufacturers that provide this type of tables with the gun designation, like with the outside diameter of the gun system, SPF, shot per foot, how many shot per foot, charge name, what charge is used here. You can see RDX, HMX, etc. These are some part numbers. 1 hour temperature rating, or what temperature this gun system can tolerate during 1 hour. Explosives loads in grams, how many explosives in each charge, and through which casing it can be run through, entry hole, penetration length, and these are the tests, test results from the tests. This is the section 1 test, section 4 test, entry hole, and the penetration. And those are when those tests performed. Okay, so that is given to understand to correctly design your perforation, so you can choose correct gun system for your well perforation. Can you hear me well?
Yes,
Is there any problem with sound quality? Sorry.
No.
Okay, let's continue because someone is asking about sound quality. Next chapter is, next topic will be perforating gun system classifications. How do we classify different gun systems? So there are a few types of classifications. First, the gun conveyance method. How we deliver the gun system into the well, into the zones that we are going to perforate. First is the wireline through the casing, wireline through the tubing, coil tubing, or drill or tubing string. Okay, so we may run the gun into the hole using a wireline, and using wireline we can go through casing or tubing. We can run with coil tubing. We can run with drill tubing string, drill string, or tubing string. We will consider all of them in sequence in next chapters, next slides. Another classification is, type of classification is time of perforating. Before the completion of the well, i.e. through the casing, or after the completion which will be through tubing or tubing conveyed guns. Retrievability of the gun and charge carriers are also type of classification. So we have a retrievable with the perforating charge mounted into a steel tube. So we run the guns into the hole, into the well with the hollow carriers, or expendables with the perforating charge mounted on metallic strip and exposed to the well fluids. And this type of gun systems are expendable. It means we just charge it, and then they are destroyed, those strips, and the debris are left in the wellbore. And these are very light materials that are carrying the charge, and they are destroyed during the perforations. They are easy to And we will talk about some specifications of those in next slides as well. Also, sorry, there are different methods of perforation based on pressures in the wellbore during the before and during the perforating. Overbalanced, underbalanced, and extreme overbalanced. And there is also dynamic underbalanced, which is part of the underbalanced. We will also, so underbalanced, just for introduction, when the pressure in the wellbore before perforating is below the reservoir pressure or formation pressure, and overbalanced when the pressure in the wellbore is above or exceeds the reservoir pressure in the formation. Okay. So gun conveyance methods are shown here by schematically. So the first one on the left-hand side is the wireline perforating. So we drill the well, complete the well with the casing and liner and then run into hole the wireline or on coil tubing, and then perforate the casing. And this is the done pre-completion. We can run the wireline after the completion or coil tubing through the tubing, okay? Or we can do it as a tubing conveyed perforating when the perforation, in all first two cases, is it wireline or coil tubing or hydraulic workover unit, the tool or the guns after the gun system after the perforation is pulled out of the well, okay, and then we start production. Sorry, but in the tubing conveyed perforating with completion, we run the perforating gun at the end of the tubing as a part of the tubing string, and then fire the guns, perforate the well, and start producing. And this gun system is dropped by these firing heads, and we release the gun on drop it into the wellbore, for which we drill additional few meters as per the perforated interval, some depths. So the gun is dropped into the sump to not to obstruct the flow from the wellbore, from the reservoir into the wellbore. Okay, so this gun system, in this case, when we run tubing conveyed perforating system, is dropped into the wellbore. The same system is applied here, but here we may drop or may not drop. We use a retrievable packer to perforate it, then test the well for DST or whatever, to understand, to measure, to obtain data information from the reservoir in terms of reservoir permeability, reservoir characteristic, pressure, etc., etc. And then very short production time. After very short production time, we pull out of the well this system, the drilling pipes as well, and then complete the well with tubing to start permanent with the permanent tubing to start the production. Okay, so a little bit details of each type. Wireline guns are run before the installing the tubing. They are run with the, we don't need the rig or derrick for these wireline guns. So it's run on the cable. We run this through the casing. So gun length, of course, here is determined by maximum allowed weight. Depends on the wireline diameter or this cable diameter, or lubricator length. Lubricator, you know, is the equipment to provide a pressure isolation on the top of the wellhead. When we don't use rig, we use wireline service system. Lubricator is providing pressure isolation, and the length of this this lubricator, of course, the length of this gun system should not exceed the lubricator length. Okay, it is the another restriction is the weight. It should not exceed, as we said, the strength of the cable that is carrying it. To perforate long intervals, we have to go, if there is a long interval to perforate, we have to go several times into the wellbore with the wireline gun and perforate it and run out of the well, pull out of the well, then run in another tool to perforate another interval. So it is time consuming. So every time we have to run into hole, one gun system, fire it and then pull out and then run into hole another gun system to perforate another zone, etc., etc. And this is usually done under the overbalance perforating, because here we haven't completed the well. The well is more or less exposed to the pressure from the reservoir. Therefore, the maximum of 500 psi under balance may be allowed, and that is still not desirable. But sometimes we, taking into account the well conditions, we may have some under balance wellbore pressure to provide better perforating quality. But you have to take into account that only first run can be applied, can be run or can be perforated with the lower under balance conditions. If we have to run into hole for the next zones, then the conditions should be overbalanced. Sorry. The advantages of wireline casing guns are the high charge performance, because the large diameter guns and charge can be deployed because of the, now we are running through the casing. There is no limitations on the gun size except the casing diameter, and minimum clearance of ½ inch is very advantageous for the gun performance, charge performance as well, and the low cost, higher temperature and pressure rating, because we are not staying in the well bore too long, so we can use a high temperature rating for short period and perforate more efficiently. High mechanical and electrical reliability, minimal debris and minimal casing damage, because we are running it with the scalloped or the gun system that all the debris are stayed in these hollow carriers. Instant shot detection. What does it mean? When we pull out the gun system after the charging, we can inspect the gun and see which charges were shot and which were not. Okay. Also, this allow multi-phasing hot shot density and large charge size to be used because of the large gun size, gun diameters. And speed and accurate positioning using CCL gamma ray during the wireline running into the wall bore. Okay, you have seen this wireline, surface wireline equipment. This is the lubricator, and we run these through the lubricator. These are the wireline going into the well bore with the tools at the end of this wireline. When we use, and sometimes we use the wireline conveyed guns through tubing. When it happens, for example, if we need to have larger underbalance to test the well or to start producing, or we may have a reperforation job to be done, and to reperforate, we have completed the well already, and we have to reperforate the new zones or the zones that are not producing efficiently. Then we can do it through the tubing. In this case, of course, the tubing diameter will be limitation. So the guns will be, the gun diameter will be now determined by the tubing diameter, and that is if the that's of course causing some problems during the perforations, the after perforations. For example, the guns may be damaged or blown up the well bore if too high underbalance pressure is applied. We have to go from lower interval to the upper interval, and the standoff here is very problematic, because the smaller diameter, as we mentioned before, now the centralizing this gun, especially if the well is deviated even at very low angles, then the centralizing this gun is very difficult, and usually they use a decentralizing or area orientation devices that we mentioned, like magnetic, to stick to the casing wall, so we can direct the perforations, direct the shots into the desirable orientation, desirable direction. So, summarizing, key point of the wireline conveyed perforating are the rapid. So it is a limited exposure of explosive to high temperature. So we can use high temperature short time explosives. Repetitive, this is a kind of negative moment, but limited perforating conveyed allow it. So therefore we have to, if we have long zones to be perforated, then we need to run several times the wireline into the wellbore to complete the perforations. Another positive moment is that rig is not required, which is very important because, as you know, rig is one of the cost-effective kind of so the every day of using the rig is very expensive. So any operations using the rig is adding very much cost on the total operations. Therefore, avoiding the rig usage, saving a lot of money for the company, for the project. With the wireline gun, we have to operate daytime. Guns are retrieved. We can inspect the gun's performance or charge performance. Gamma ray and CCL used for depth control, which is also good as we can do better reference with the GR and CCL. Limited underbalance available to clean perforations. Maximum 65-degree well deviation for wireline operations, again because of the gun centralization, as well as because of damage to the cable when we run the cable into the hole exceeding the 65 well deviation. Debris can be accumulated between the perforating rounds when using the expendable guns. As I said, the debris from those very light materials are accumulated in the wellbore. So depending on the run times and depending on the how long these gun systems, these debris can be dangerous for further operations, for intervention operations, as well as can be obstructive for the production fluids. Tubing conveyed guns. Tubing conveyed guns may be left in situ, dropped into casing or rat hole, or recovered prior to running the final completion string. These are the last one is used when we referring to the cases when we run a coil tubing or drilling string as a to convey the guns and perforate the wells. Okay, here we can apply well. Here we, as I said, we attach the gun system to the end of the tubing string and run the tubing with the gun system into the wellbore. And what happens here? So as long during the running the tubing string into the wellbore, the gun system is under the wellbore conditions, be it temperature or pressure or any other effects. So therefore, and depending on the depth of the well, depending on the severity of the conditions, these guns, these charts might be a affected the temperatures and pressures, although pressure does not affect too much, but temperatures, wellbore temperature is affecting the gun and charge performance. So therefore we may think about the perforation design with the explosives chosen correctly for this type of perforating system. So what is there are the firing head, which is maybe actuated by the drop bar, hydraulic pressure, electrical signal, or any combination of this. So we have a perforating system here, and the firing head is actuated by or detonator is actuated by, it can be drop bar. They drop a bar from the wellhead into the wellbore, and that is actuating or detonating. We can use hydraulic pressure, or we can send an electric signal. And then this gun system is actuated, detonated, and we perforate the well with this gun system. So in this case, we have fully completed well. We have all valves and any accessories are installed into the well. And those, for example, downhole test valve may allow fluid flow after the perforating, right after the perforating, to test the well. Or we may drop the gun from here. This is the gun drops up. It means the gun will drop from this position into the wellbore. It can be run again, as I said, with the conventional drill stem test assembly. The well is produced clean, followed by killing the well, retrieving the test ring and spent gun, and running the permanent completion. So what happens? We run the perforation gun with the drill stem test string. We perforate the well, test the well, and then produce the clean for reservoir fluid with cleaned perforations, cleaned formation, and then killing the well, retrieving the test ring or the drill stem test string with the spent gun, and then run the permanent completion with the required tubing, required accessories, etc., etc. We can run it on the coil tubing and retrieve it the same as the killing the well. Here we can do also through the tubing and the casing. So if we run it through the casing, this will be the almost the same as the drill stem test, but here we use coil tubing. Again, no rig is required. Or we can use it through the tubing, but in this case the the gun diameter will be again dictated by the tubing diameter, and still no rig is used because coil tubing does not require rig. Run the gun as a part of the completion string, as I mentioned. Then the gun is attached to the tailpipe. The well does not need to be killed to pull out the perforating systems and then complete with the permanent completion. Guns are normally detached and dropped into the sump. This is becoming more common because it reduces the rig time, lower formation damage, although it has some disadvantages, but let's first go for advantages. High power charge possible, because now we have tubing string and everything, or drilling string are in place. So high power charts or the all perforation phasings, all shaft densities can be applied, because this is kind of fixed system. It is not wireline to so it is stable and fixed equipment on place. We can perforate long intervals in one run, because again this is stable and fixed string, and we can perforate more than 1,000 meters of intervals. We can perforate in underbalance or overbalance, same for all perforations, so we don't need to use underbalance for the first run or then overbalance for the second runs. Guns can be run in highly deviated or even horizontal wells or through high doglegs. So because these guns can be stacked over each other, so we don't have to have the one run of this long perforation gun system. We may have a stacked perforation systems to run through the high doglegs, and we can do it in any deviation or horizontal wells, because the tubing or drilling stem drill stem test are all fixed with the centralized with the packers, which is more important with the packers. There's no problem with the standoff or clearance. Some disadvantages, rig required, of course, which is expensive for small or separated intervals. We have to drill a sump zone to drop the guns, and or in other case, if we don't drop the gun, if we leave the gun here, then we wouldn't be able to run production logging through the producing intervals or any other interventions where we need to go through the production intervals to see the performance of those intervals. If there is any problem with the gun misfire, or some if the gun is not detonated, then the completion needs to be pulled out. Full completion need to be pulled out of the well, inspected, tested, checked, and then run into hole again. And this is a first of all rig time, which is expensive, very expensive, and just for reference, some offshore rigs cost might be around $100,000 per day, and onshore rigs might be $10,000 to $30,000 per day. So every day you are using these rigs will cost the company, depending on the location, very large amount of money. And the safety, again, because as long as the guns are not fired or exploded, then there's no guarantee that when you pull out the well, it might be exploded or it might be detonated at any time, either in the wellbore or when the pulling out the wellbore. Of course, to recover the gun, to pull out the tool, we have to kill the well, which may lead to impairment, impairment means the formation damage or any other damage to the wellbore. Sorry. Performance of uncovered guns not confirmed, so we don't know which guns perform, which charge performed, which charge didn't shot. Explosives can degrade. We mentioned it because of long time of high temperatures, and of course potential for completion equipment damage on firing. Okay, so these are for retrievable and expendable guns. Our time is over now. So, is there any questions? Hello?
So far, there is no question.
Sorry?
I don't have questions so far.
Okay. Anyone? Any questions? By the way, about the tutorials and the activities, only Emin sent me, I asked you to go through those charts of KV, KH, influence of perforation density and vertical and horizontal permeability on well productivity, and only Emin sent me his thoughts about this. So I still would like to have your opinion. Why, for example, but why these differences between the shots per foot because of the KV/KH ratio, etc., etc. I mean, you gave some interesting points, but you just stated what you see from the chart. But I would like, thanks for that, good observations. But I would like to have some explanations also why this kind of change happens because of KV/KH ratio change. Okay, so I would expect everyone to do that analysis of this plot, this one or this one. Those are in your books, so you can easily find those plots and give your thoughts to me by email so I can see how do you interpret those plots. This is part of your job as an engineer, and this would be good to have your view on this, to understand your perception of the matter.
Sorry,
Okay?
can I ask a question?
Yes, please.
Can we say that state of this graphs, I mean KV over KH graphs, depend on type of like for horizontal or for vertical, this can be different.
Okay, what I'm asking you to look at those graphs and write your thoughts on the paper, let's say, and send it to me so I can go through and kind of assess, or, well, not assess, but to see your view, your understanding of this. I needed to understand how you see this, perceive this relationship. Okay. So whatever you are thinking about that, please provide it on a paper, on a Word document, or any other type of document, so I can see it. We can discuss it in the class, but we have limited time, so you can do it on your tutorials if you like, with the tutors, Mehmet Melim or Elnara Khanım, whoever is yours, and then based on these discussions, write a couple paragraphs or half page. I don't need too much. A few lines of the explanations. How do you see this interpretation of those plots? Okay. Orhan. Orhan küstü. Okay, next, if I'm not wrong, is the Group 1 FTP discussions, correct?
I'm sorry, don't we have it tomorrow? We usually had those discussions on Tuesday.
Oh, today is Monday, sorry.
Yes.
Okay, sorry. No, of course, yes, tomorrow. Tomorrow after the lecture.
Okay.
So, thank you very much. Is Temkin here?
Yes, teacher, I'm here.
Okay, we are meeting now.
Yeah, I know. I will